Okay, so let's go to number 4. Number 4, I'm not even sure what we were. Okay, we got $7 here, correct? And so we took the original equation, and so we did d of z equals 7, correct? Which then equals 4/10 z plus 5. First thing we did was subtract the 5. So really what I'm wanting you to walk away with right now is the notation we're using. So then I want you to notice I'm not dealing with this decimal. I'm going to turn this into 4/10 again. How do I make 4/10 go away? Okay, so I'm going to multiply this side by 10 over 4 times 2, which equals z. So then 2 goes into 10, what, 5 times? No, I don't even know what I'm thinking. 2 goes into 4. Why are you saying 2 goes into 4 2 times, and then 10 divided by 2 is 5 ounces. We okay with that? Okay, and then we have this one right here. I'd call him by name, but I don't want to on the recording. So this person right here did a fabulous job of writing, not F, D, D. No. This person did a fabulous job of writing Z of D. Because you'll notice now the input has changed. So anytime you take it and you solve for the other variable, you found the inverse. When they do funny variables like this, we don't necessarily switch the x and y. So this is the inverse, and both of them are functions, so we could use function notation. Okay, now we got some stuff going on down here. Okay, this one right here, this is 10 ounces. So we're going to write this one like our original. This one was dollars based upon we're plugging in 10 ounces. So that would be our function notation for that. And we got an answer of $9. And then this last one was done using the original, but it also could have been done using the Z of D. And if we used that Z of D, we would have put in the dollars. Hold on, I'm going to move this. So we could have put in the dollars, which were 10, 9, minus 5, and divided it by 0.4. That goes with that formula we just had a minute ago for Z of D. And then this would have gotten us to our $10. Make sure when we write any answers, we always put, our units or whatever we're talking about. Are we okay with that? All right, let's look at these. These are a lot like solving for inverse functions. They're called literal equations. Why? Why is this equation right here different from the ones we've been doing? Yeah, it only has letters, and because it only has letters, we kind of freak out. But we're going to do the exact same thing. Our goal is to solve for x, which means we want to get x by itself. So if I was going to solve for x, what would I do first? I would totally subtract the b. So when I go to subtract the b, I'm going to get y minus b equals mx. So now I got y minus b equals mx. I still don't have x by itself. What would I do next? Definitely. So if I divide by m, I get x equals y minus b over m. Are we okay with that? Looked worse than I think it was, I hope. Let's bounce over and do the other one that we had over here on A. This one actually has a number, but, it doesn't really matter because there's so many letters in there. So our goal, once again, is to get x by itself. So what would you do first? Subtract the 4. Is there something else we could do at the same time?
Add the z.
I could totally add the z, which means I'm going to end up with x over y equals m minus 4 plus z. Okay, now what do I have to do to get x by itself?
Multiply by y.
The y is dividing, so we're going to do the opposite and multiply. So I'm going to get y times m minus 4 plus z. Notice how I write it, my equal signs. I want to line them up. I don't have circles going on. I don't have work over here and there. So let's keep it moving downward. So then we got B. Oh, no, let's do B last. No, let's do B last. Let's do D. This one I want to solve for x again. What would I do first? So I get y minus k equals x squared. How do I get the squared to go away? Square root. Do you currently see a square root?
No.
Okay, so anytime you bring a square root to the party, you have to remember to bring plus or minus. So I have plus or minus the square root of y minus k equals x. We okay with that? Y'all are awesome. Let's look at C, B, whatever. Okay, now we want to get this r by itself. There's all kinds of stuff going on. What do you think we want to do first? And what else? Yeah, perfect. We got pi r squared h being multiplied, so let's just get the pi and the h to go away. So we end up with volume over pi h equals r squared. Okay, now how do I get rid of the squared? And what do I have to remember? So plus or minus, make sure your radical is big enough that the denominator fits inside of it. And there we go. We okay with that? Okay, those are practicing with literal equations. Now that we've done that, let's go practice with some actual functions. This is a function. It graphs a line. If I graph this line, it's going to pass the vertical line test, and I know that because they're telling me it's a function. In your brain, I'd like for you to picture what this function looks like. Will it pass the horizontal line test?
Yes.
So the y's do not repeat, so therefore its inverse will be a function, which means we can use function notation when we finish. To find the inverse, all I want to do is swap the x and y. Remember, f of x is the exact same thing as y. So now I just need to solve for y. So what would I do? So I'm going to do x plus 12 equals 6y, and then totally. So I got y inverse, and I'm going to have x plus 12 over 6. Now I'm going to simplify this. Here's my function notation because I know it's a function. But now I want you to think about x over 6. What is x over 6? Because I want to write my slope. Excellent. 1 over 6 x. And then I got 12 over 6? 2. We okay with that? Because it was a function, I got to use function notation. If it was not, I would have had to leave it as y inverse. Okay? Y inverse we'll use when it's not going to be a function. So when it tells you to use proper notation, that's what it's saying. Is it a function? Then use function notation. If it's not, y inverse. Ooh, this one. It's a function, and I know it's a function because it tells me when it says f of x. It means it's going to pass the vertical line test. If I graph this, what kind of graph is it? It's not an exponential. That's when you got the little x up there in the exponent. What is it? I heard it. So it's a quadratic. Is this thing going to pass the horizontal line test? What do you mean yes? No. The y's are repeating, right? All except for the vertex. So therefore, when we get to the end of this, we would use y inverse, or we'd restrict our domain. Okay? So we're just going to use it as y inverse. So I'm going to swap my x and my y. Okay, now what? No, you can't distribute because that stuff has to be squared. Remember, our goal is to solve for y. So what do I want to move away from y first?
6.
No, you can't. You can move the 6. So we're going to do x minus 6 equals 3, y plus 1 squared. Now what do we want to do? Totally. We're going to divide by 3. Then what? Now we've got the squared all by itself, so this would be the moment when we can square root it. What do we need to remember? So I got plus or minus the square root. Make sure it's big enough that you can keep that denominator in there. And that's going to equal y plus 1. Now what? So I'm going to get negative 1 plus or minus the square root of x minus 6 over 3 equals y inverse. Okay, now yesterday, do you remember when we did our fold over of our quadratic? How did we make it to where our inverse would be a function? We restricted the domain. And we restricted the domain at the vertex. Can anybody tell me what the vertex for this one's going to be? No, it's totally not. HK. It's going to be negative 1, 6. I don't care anything about this. I only care about the negative 1. So we're going to restrict the domain, and we're going to say we're going to go from negative 1 to infinity. That means we'll keep the vertex in the right side. So now when we go down here, how should we rewrite this so we can rewrite it as function notation? What do I get rid of? No. I get rid of the minus, right? Because we crossed off the bottom. So I just have plus the square root x minus 6 over 3. Because we scribbled off the whole bottom part of our graph, which was all the negatives, correct? That's all we got to do. We good with that? Okay, let's do our little box. I have something to put in your box. Let's see what I want to put in your box. Let's put writing inverse functions. I'm not sure why we get stuck on this idea. If I give you a table, can you find the inverse? What would you do to find the inverse? Swap the x and y's. So here you do the same thing. I want you to just switch the x and y's. So if you have an example of y equals 2x plus 4, all I want you to do to find the inverse is to do x equals 2y plus 4. Subtract the 4, divide by the 2, and you have the inverse.